And thank you for joining me today as we begin our discussion of water and some of the properties that go along with water. This unit's on water and solutions, so we'll talk about solutions, suspensions, and colloids, and we'll go a lot into solutions because there's just more to do with those. But here we're going to get the basics of water. And so to start, goals for the end of today. You're going to explain how hydrogen bonding works in terms of water, in regards to water, and then define and name two properties caused by this hydrogen bonding stuff. Okay, so for starters, water is a polar molecule, meaning that electrons are not shared evenly between the oxygen and the hydrogens. So because we learned in Unit 3, we talked about electronegativity, because oxygen is a very electronegative element, it's going to hog those electrons when it's in a bond and going to become slightly negative. It's got a partial negative charge. The hydrogens are less polar or less electronegative, so they're going to have a slight positive charge. And this creates water. This enables water to be a polar molecule. And it's got a slight positive and slight negative end. Okay, and this causes the hydrogen bonding. So this hydrogen side attracts to the oxygen side of another water molecule. And we'll look at this diagram-wise here in a minute. With some different things that happen because of this. We have cohesion and adhesion. These are the two primary forces. Cohesion is the attraction of water or polar molecules to themselves. Think of cohesion as cooperate. You cooperate with people on the same team. You're wearing the same colors, doing the same thing. You're essentially the same stuff. Adhesion. Think if you're adding someone to your team or to your agenda, you're adding from the outside. So this is the attraction of water to other substances, other polar substances. It's called adhesion. And then we have some different properties, things like surface tension. We'll talk about that is capillary action again, and vapor pressure. So these are some things we're going to talk about today. Okay, so water in general. Water has a pH of 7. We're going to talk more about this in the next unit. We talk about acids and bases. But what this means is the hydrogen and hydroxide concentration are equal within a given liquid or a given substance. So pH is 7 means that hydrogen and hydroxide are equal. But beginning again, because oxygen has a greater nuclear charge than hydrogen, it's more electronegative. Electrons spend more time by oxygen, giving this that slight overall charge, which we call polarity. Okay? And so this is how water molecules line up. This is that hydrogen bonding. So this hydrogen has slightly positive because it doesn't have the electrons, is going to be somewhat attracted to this oxygen molecule here. So positive hydrogen is slightly attracted to this negative side here. That's what these dashed lines are indicating, is a slight positive attraction or slight attraction. In the case of water, like liquid water like we think of, these bonds are extremely weak. And they're continuously breaking and reforming. So these molecules are kind of spinning and forming those bonds as they spin. So those bonds will break and reform as these guys rotate, however they darn well please. Things are constantly spinning and rotating and moving. So the bonds don't last, but they do form and reform and break and get reformed again. Okay, when we talk ice, now, ice is a solid, and so if we look at just how particles move in a substance, liquid particles can flow past one another. So two liquid molecules are able to slide past one another here. However, if they are a solid, they are stuck kind of side by side. All they can do is vibrate in place. Okay, so in the case of ice, when it comes to hydrogen bonding, so all the blues are oxygens, and the little red dots are hydrogens. Okay, if it's bonded with a purple line, this is telling you it's actually covalently bonded. So this oxygen is covalently bonded to these two hydrogens. That's my water molecule. And then there's this green or this blue arrow here, that's a hydrogen bond to this other hydrogen this way. Okay, so the blue arrows, the blue lines are hydrogen bonds, the purple lines are covalent bonds. Okay. As molecules slow down, as water slows down, these hydrogen bonds on the waters arrange themselves to maximize this hydrogen bonding, because positives don't like to be near other positives and negatives don't like to be near other negatives. They maximize this space. And so the reason that ice actually floats is because there's this gap between these molecules. And we'd like to think that there's air or something in this gap. This is actually empty space. And it's not huge because atoms are super tiny. But this is actually empty space. So the reason that ice is less dense than water is because these molecules are spread out. They maximize their space they can take up, which leads to lower density and these ice crystals forming. This is why when water freezes, it expands out. It's because it has to line up like this so that it can maximize that hydrogen bonding. Okay, so some properties caused by these hydrogen bonds. We have cohesion and adhesion. These are those two forces we're going to talk about. We also have capillary action, surface tension, and vapor pressure. So here we go. Let's get started. Cohesion is the attraction of one molecule to another molecule of the same substance. So these water drops are bonded to themselves. That is cohesion. So we're going to think of a team. You are working together on the team, and you want your team to do well, so you are bonding to your teammates here. Okay, that's cohesion. The next one is adhesion. This is where, oops, I lied. We're going to do surface tension next. But surface tension is when this cohesion makes a layer on top of the surface of water. So the reason that a belly flop hurts in a pool is because all these molecules are lined up and they're set to stay together. And they've created this skin-like layer. So this is that flexible sheet, kind of like a skin-like layer, allowing sometimes denser objects to float on the surface or sit on the surface. So this is surface tension. This is cohesion at the surface. Here you see cohesion, surface tension in action. So we know that paper clips are made of metal. Metal is more dense than water. However, you can actually take a paper clip. If you put some water even on a plate, you can float a paper clip on water. If you are able to set it on there without breaking that surface layer, you can set the paper clip on the surface and it will sit on top of the water because of that surface tension. So this is actually kind of cool. And then you can take another paper clip and push it around and move it. But once you break the layer, then the paper clip falls through. So it's kind of tricky, but you can give it a shot at home. You can use a bowl or a plate, or if you're in school, I can get you one of these watch glasses. You can try it there. Another property, vapor pressure. Vapor pressure. This is the pressure caused by water vapor above a body of water. So particles in the water, molecules that are in the air above the body of water is vapor pressure. So pressure exerted by the vapor. Water has a very low vapor pressure because we don't have a ton of water molecules in the air. Even on super humid days, there's still, there's a lot, but not to the extent that others can be. And so because of this, water easily evaporates, especially on dry days. Water evaporates super quick because the air has plenty of space to hold it. There's not a ton of pressure from the vapor, so water can go from a liquid to the gas very quickly and very easily. So this is vapor pressure, the pressure exerted by the vapor above a body of water. Adhesions. This is our other force. So cohesion was the first one. Adhesion is the attraction of one polar molecule to a polar molecule of a different substance. For example, water bonding to things like soil or clay or glass. Even our clothes can bond to water a little bit, or polar substances. Animal hair. paper, straws. All of these have adhesive properties where they are attracted to water. In the case of glass, we see this with our glassware. So graduated cylinders, for example, have um, when you put water in a graduated cylinder, it forms this little U shape. That's because it's being pulled up on the side here by adhesion. So that is adhesion in action. You actually see this all the time. Capillary action is kind of an advanced form of adhesion, kind of cohesion and adhesion together. This is the attraction of water molecules to positive and negative charges. In paper, this allows water to move up a column. So for example, we can use straws in this case. This is how trees work. So trees actually pull water from the ground all the way up through the leaves to be pulled out into the atmosphere. So, capillary action, super important. This is how our trees get water. This is how we suck or we pull water up a straw. It is in part by this capillary action. The water will kind of force its way up the straw a little bit on its own. Okay, so this is capillary action. This is our last property of water we're going to talk about today. So to review quick, I would like you to name the two forces. So what are those two big forces that are caused by hydrogen bonding? And then give me two properties of water resulting from hydrogen bonding and describe them to me. So define them. What happens? What makes them unique? How are they different? But thank you for joining me on today's discussion of water. I'm excited to go through this unit with you, and I will see you again next time. Take care.